Okay, so I'm using the book Thomas and Fanny Calculus. So in that, the last I wanted to just give you the formulas of that. The first one is the formula for volume. The topic is find the volume by finding the by slicing your, see if you are having a something cylindrical, you can say, and if you want to find the volume, then what will you do? You will slice them into n part, or slice them and find area of each part. It is something like cube. Just I'll just quickly explain you. It is something like uh, you can understand by set of breads. You know the packets of bread, it contains so many breads. So if you want to find all volume of that part, so you just have to find uh, area of each area such that this height is one, each height is one. So you just have to find area and then add them all, you will get the total height. See what is the formula for this? LBH. Do you remember? Do you remember that the formula for cuboid is LBH? Now if you find L into B, that is area of first part, then if you add this L into B is multiplied with 1 plus 1 plus 1 plus up to H, up to H. That means what? This one braid you can consider L into B, or you can say denominator. Actually I should have इसको हाइट नहीं बोलना चाहिए था मुझे. Let me put it, this is B, this is H. Okay, so do you see the first braid? The area of first braid is L into B. Perfect. And I'm considering the height is 1, so unit height means I'm talking about width. Their width is 1, and I am adding one more braid. I'm keeping one more braid, one more braid, like that. So L into B is adding, I'm adding it H times, correct? So this will be L into B into H. So, and listen one more thing, this need not be only integer, it may have, I can put half of that, it is just height of that. Okay, that doesn't matter. So do you understand? You can find the area of volume by finding the sorry, you can find the volume by finding the area. Just you have to multiply. See here also. Now in our case, what I am going to do, I'm going to volume is equal to integration e to b a of x dx. Suppose your e of x is constant, then what will this become? Suppose a is constant, suppose I will write e as it is, and integration e to b will be b minus a. Do you agree? Do you agree? And do you see this will be a volume area into this? Just now I gave you example, area was L into B, and into height, in our case height was H minus 0. Here it is B minus A, that's it. So you just have, in the question you will be given with area, or you have to find the area, or you must be knowing the area. There is no issue of that. Please write the formula to find the volume, that is V is equal to integration e to b a of x dx. Where this a of x is area, huh? Make sure this is not a arbitrary function, this is the area function. You can see some example. There is a pyramid, 3 meter height, has a square base that is 3 meter on a side. Okay, so if I take one bread, one slice of that, then what will be, it will be a cube form, so area will be x square. Do you agree? Hello, can you hear me? Yeah, good. So similarly you just have to, if you want to find the volume, then this is the way you just find the area, correct, and it will done. See, this is a special type of, this is not a cone, I should say. Cone is wait, cone is something like that. but here the base is your square. Correct? Yeah. So what is the formula, do you know? This is 1/3 of LBH actually. This is this part I'm talking about. So this is actually, you are having a cube, and this will be 1/3 of your cube. 1/3 of your cube. What is the cube? What is the cube here? 3 cube actually. So whenever you are having something like at the each endpoint, you are connecting it with any other guy, any outside guy, then the total area, total volume of this guy, volume of this thing, it will be 1/3. It will be multiplied by 1/3 with the total volume. Like in the case of uh, cone, what is the formula? Do you understand what is the volume? It is pi r square h 1 by 3. Do you agree? What is the volume for pi? What is the definition for pi r square? This is volume of a cylinder. So in a cylinder, you are just at the each point, you are just merging it to a point. Do you understand that? Then only then you just have to multiply 1 by third, 1 by 3. Here also you just have to multiply 1 by 3. Is that clear, everyone? Do you agree? Yeah, good. These are the you know, even aptitude questions are like that. People used to ask. See, so the diagram is very bad here. You can just go through with the questions. You just have to find A, that is area, and just put it in the integration formula. Next most important thing is this: volume of a solid of revolution. You please write this formula also. Volume of a solid. What do you mean by this? Let us first just quickly write the volume of solid generated by revolving about the x-axis, between the x-axis and the graph, the continuous function y equal to rf. Then v is equal to integration e to b pi r square. That is e to b pi r square. R is a function, radius function. So later on we will change this formula into another form. Don't worry. So first let us understand what is the meaning of that. Okay, suppose let us understand something like this. Suppose in xy plane you draw on a graph. Suppose this is a graph. Okay, now if you revolve this curve around this x-axis, if you revolve this curve, do you see you will get something cylindrical thing? Do you see that? If it was just a straight line, then you must have getting a cylinder. You get that? If we revolve this curve around this, considering this as axis, and you revolve this curve, correct? Then whatever volume you are getting, you can find that volume by using this formula. Volume of a solid generated by revolving about the x-axis and the region between x-axis and this region, okay, like that. Do you agree? So for these all things, we are just given the formulas. We just later on in TYBSc we will prove the formula. If you go in TYBSc, you'll see that I have proved. Even in the video lecture, if you see, I have proved in the last or second last lecture. I have proved the formulas. If you are given about y-axis, then do you see the changes? Volume is equal to, here it is dy, and your function will be in terms of, that is quite clear actually. You already know, if you are revolving around y-axis, then it will depend on dy, and function will be in terms of y. Let us see one example. Find the, can you see properly? Yeah. Find the volume of solid generated by revolving the region y equal to root x and the line y equal to 1, and about the line y is equal to 1. Okay, about the line y is equal to 1, that means what? Which line is this? About the line y is equal to x. Y is equal to 1. Yes. Do you see that? Y is equal, and this is same as x-axis only. Do you see this? Y is equal to 1. This is same as x-axis only. Correct. Now let us see. The thing will be that curve का जो entry point and exit point that will be changed. अगर यहाँ पे होता तो एंट्री पॉइंट 0 से लेके 4 तक होता, बट अभी क्या रहेगा, जो कर्व पे कट करेगा दैट विल बी माई एंट्री एंड एग्जिट पॉइंट. दैट डू यू एग्री दैट? Yes. And they have given y is equal to 1 and x equal to 4. If you put y equal to 1, you will get this point as 1 1 and 1 4. So you have got your function. That is, what is your function? Function is your integration 1 to 4 pi rx the whole square dx. What was the rx? Rx will be working as this radius. This is called radius function. Okay, so how can you find this thing? I already told you, you just have to insert an ray. If you insert a ray here, then you just have to subtract upper curve minus lower curve. What is your upper curve? That is root x. And what is your lower curve? Y equal to 1. So you have to subtract root x minus 1. That will be your function. That is your function rx. That is pi bracket open root x minus 1 the whole square. That is, in the formula it was pi rx the whole square dx. Is that clear, everyone? Now you just have to solve the integration. That's it. Do you understand how did we find the function rx? This is actually area under the curve, you can consider. Actually, in the area under the curve also you are doing like this only, upper curve minus lower curve. Do you understand? I had given some examples. If I am having two curves, I want to find area under the curve. You just have to put upper curve minus lower curve, because if I put upper curve it will give my area under this whole part. Then if I put lower curve, then it will subtract this part. I hope that is clear to you. Okay. Same thing, area about y axis, the same thing, it will be changed to with respect to x हो जाएगा, बाकी कुछ नहीं. Sorry, मतलब this formula with dy हो जाएगा. यहाँ पे ry will be again upper curve minus lower curve. Upper curve here it will be in terms of y. So lower curve is 0, upper curve is 2 by y. So ry will be 2 by y. Just put it in the equation and you will get that. Okay. Yeah, the same thing. If you want to find area, something like that, let me show you. One like this and one like this. Okay, so this is also volume of revolving, but you want to find just inner part. So to find the inner part, you already know what is the trick, correct? You just find the total volume and subtract this volume. So both the volume is here revolving wala, correct? So you just have to pi. That is quite clear. There is no need to give a separate formula for that, correct? I hope that is clear to you. So you will be given two curve here, and then you have to revolve. Just look at this example. So here this is the two curve. If you revolve this thing, then you will be getting this type of figure, correct? If you are having this type of figure, then what is the next thing you have to find? Find what is your capital Rx and what is your small rx. That's it. Because in this case, do you see that capital Rx will be this part, this line, and small rx will be this line, correct? Because your volume will be inside part. This will be something like that. Something revolving like that. This will be something like a pipe. You want to find the inner part. In earlier cases we were not having a upper bound, we were just having something like this. So if you revolve, then this will give a volume under that, but now we have to subtract that inner part. Just go through with the example, that is quite easy. Same thing here also. Here this is the curve, so if you revolve, the inner part will form a cone, that is quite visible to you, and the outer part it will form a like a ball shape, or you can say maybe parabolic form, paraboloid. That is called paraboloid. It is in XYZ plane. Okay, so that was finding the volume. This part is not in the syllabus actually. I will skip this thing. One more is there, arc length. Finding arc length by using, yeah, here. So first you need to know the definition. What do you mean by smooth curve? A function with continuous first derivative is said to be smooth, and its graph is called a smooth curve. Okay, a function, if you are given a function, find the derivative of function. If that derivative is continuous, then you will say the function is smooth curve. Yeah, so here is the definition. So now we want to find arc length of a curve. See, remember, in this SyBsc you are just given directly the formula. In your TYBSc we are going to learn how this formula came. Okay, we will be proving this. If f is smooth on AB, and you already understand now what is the definition of smooth. The length of the curve y equal to f of x from A to B. You can find the length of curve y equal to f of x by this formula, that is L is equal to integration A to B square root of 1 plus dy by dx the whole square. You just, अगर curve दिया है y in terms of x, then you just have to put the derivative and put it inside here. और अगर ऐसा है, integration A to B 1 plus f dash of x the whole square, then like this. Okay, and one more form will be there. If your function is in parametric form, then also you can find the arc length. You quickly please write these two things. Both are same actually. At the place of y you are putting f of x, and we also write the equation like this: y is equal to f of x. So please write the formula. I'll give one more formula for that. That is, if your function is in polar coordinate. Do you understand polar coordinate? That is, x will be in terms of some t, y will be in terms of some t, something like that. Then also you can find, you don't have to convert that polar form into this Cartesian form and then apply the formula. I hope whether they have given that, not. Yeah, yes, here it is. Integration A to B square root of dx square plus dy square. Dx is your partial derivative with respect to uh, uh, partial derivative of x, and here it is partial derivative of y. They must have written it properly. I don't know. They, so you just write this like this. That is integration A to B dou x by dou t the whole square plus dou y by dou t the whole square, and put a square root outside, and this is dt, something like that. When your question is given x in terms of t and y is also in terms of t, then you have to apply this formula for finding arc length. Why I am putting A to B? Because I want to find a arc between 2 points, that is A to B, initial and final, something like that. And that point you can directly find by putting in the equation, because that is the point of the curve. Yeah, you see. And I'll quickly see you what is the theory behind this finding this. Okay, so you want to find this arc, correct? So what I am doing, I am just finding a perpendicular here. So see, this length will be dy, this will be dx, then Pythagoras theorem, this will be ds, correct? And if you make this as much small, then your ds will work as, if you add this all ds, then you will get your arc length. Do you agree? If you make much smaller this dy, then you will get much accurate your ds. I hope that is clear to you. Then just you have to integrate this thing. Yeah, do you see here they are given? So ds will be this and arc length will be integration of ds. That's it. That was arc length. Okay, I think that was the last part maybe. Yeah, one more thing is area of surface of revolution. So अभी हम लोग ने वॉल्यूम का देखा था. Now let us see finding area. That is also given by a formula only. You just need to remember the formula. Later on we will prove that. Write this formula. The surface area formula for revolution about the x-axis. Here if the function f of x is positive, is smooth on AB, the area of surface generated by revolving the curve y equal to f of x about x-axis is given by s is equal to integration 0 a to b. You just keep write this formula because you are putting y equal to f of x, then that is enough. A to b 2 pi f of x square root 1 plus f dash of x the whole square. This is also proved by using that double and triple integration later on in SyBsc. You just need to remember the formulas. There may be one or two question based on the formula only, or maybe formula is you just have to check whether in the MCQ formulas will be given. You just have to check which one is the correct. This type of question may be in the exam. If you put about y-axis, then you know the changes. Let us see an example. See, find the area of surface generated by revolving the curve y equal to 2 root x, where x is lying between 1 and 2. So what is the formula? Y equal to 2 root x, that means what? Y is equal to f of x, so f of x is in this, correct? Revolving about x-axis, you know the formula, that is s equal to integration a to b 2 pi y square root of 1 plus dy by dx the whole square. Just put it in the equation. We are given a is 1, b is 2, and that's it. Just put it in the equation and solve the integration. See here the main thing is that you should know the formula of integration, because your function may not be as simple as here in the example it is shown. Okay, and surface area for revolution about y-axis, you can see that also, that is 2 pi g of y square root 1 plus g dash of y. Or to remember quickly, you can remember this short form. Okay, so let me just quickly see. Please remember, I think कुछ ज़्यादा formulas नहीं है, 2-3 ही है. You just have to see. These all things, moments and center of moments, this is not part of your syllabus, but we will be learning this in TYBSC because we require some part of triple integration also later on. But these are also the formulas only. In your TYBSC you will be given that part, no issue. You just go through with this book if you want to refer this some topic or Thomas and Finney. If you want, then I can send the PDF also to you. Even if you search on the internet, you will find the PDF. You see, all the calculus is there. This will be used in your TYBSC also. Okay.